Thank you. It's good to be back in Stockholm. And I just wanted to thank Klaus and Patrice for that presentation. That was really interesting. One of my favorite things about traveling around to different community events all over the world is getting to hear from users. And that presentation was so good. You guys shared so much detail. And so I applaud you, not just for the work you're doing, but for being willing to talk about it in that much detail. Is so helpful for everybody else in the community. I wanted to talk a little bit about OpenStack and the OpenStack Foundation and kind of provide an update on what's been happening with the software and the community and some of the trends that we see as we go around, as we talk to a lot of different users and work with different companies. What are we seeing and what do we think that means for the future of what we're all going to be building and using together? So just a few updates on kind of the OpenStack side of things. We run a user survey, and anyone here who's using OpenStack, I encourage you to fill it out. It's at openstack.org/user-survey. And we gather a lot of data from that. We gather feedback that we provide to the software developers and the project teams. We gather usage information so we can see patterns about what kinds of technologies people are using in their clouds. And then we also just gather some statistical information that helps us understand what the state of the market is. And through our most recent user surveys, we've cataloged over 10 million cores of computing power that are running in OpenStack clouds around the world. So the thing that I think what we see, especially in about the last 18 months, is a big spike in adoption. These are production environments too that are cataloged here. So a big spike in production adoption that actually matches up to the SBAB timeline that they were talking about of the last 12 to 18 months as well. And I think we've kind of reached a tipping point in terms of people really putting this technology into their businesses and moving production workloads over to it. As you look at kind of the broader market, there are a couple of other pieces of data that I think are interesting. One is a recent 451 research report around service providers and the telecom industry specifically, and 71% of the people that they talked to were running OpenStack in production or plan to go in production in the next 12 months within the telecom industry. And so this is an industry that is also undergoing a big technology shift, and they are making multi-year and in some cases multi-decade bets right now about what the foundation of their technology is going to be. And OpenStack and open source in general is playing a huge part in that. It's a huge part of the transformation to virtualized networks, to the 5G rollouts that are happening around the world, and so that's really exciting to see how this kind of technology is pushing industries into their next phase and their next generation of adoption as well. And the last one is kind of a commercial view of the OpenStack ecosystem. IDC did a report about a year ago now, and they predicted the next several years of what the OpenStack commercial ecosystem was going to be like. And for 2018, they put that at $6.1 billion US. So that is a pretty large financial impact for an open source project to have kind of on the technology world. And when you put all of those together, what I see is a really healthy environment where you have usage growing, you have kind of foundational, very key parts of industry and business that are depending on the technology, and you see investment coming in to the ecosystem that funds further development and further progress. So just a few stats to kind of kick off the morning and give a little bit of an update about where we are. As we look at some of the more specific and kind of technology-focused pieces of it, a couple of things to point out here. This is a map of those production deployments from the user survey, and one of the things that is incredible to me is the global scale of what OpenStack has become. We have this event here. I'm also really impressed with the efforts that are happening to kind of promote and encourage open source involvement overall in this region. But one of the things that I think is really awesome about open source is when you get involved in these communities, you're actually joining a global movement and a global effort to basically build key technology and make it available to everyone, everywhere around the world. And so, when you participate and you contribute to OpenStack, it's good for your company, sure, but it's also good for thousands of other organizations all over the world. And you get to be part of kind of that global movement. The OpenStack set of services has continued to grow. This is a graphic that shows the types of services that are deployed in OpenStack clouds now. And so it's kind of broken down into broad categories like computing and networking and storage, and then the different services that are available. This is something that has been really cool to see expand over time too. The SBAB team mentioned Azure and AWS, and people love to talk about how much innovation happens in those public clouds, how many services they produce. The OpenStack community produces a lot of innovation as well, and I think that when you look at this, you can really see that and know that 8 years ago when we started, we only had 2 items up here. We had Nova and Swift, and since then, the scope of what we've done has expanded and grown, and the community really does deliver a ton of innovation, and that's awesome to see. Some of that innovation recently that's been happening in the last couple of releases are getting directly to the new kinds of use cases that we see in the world. I'm going to talk a little bit about some of the broader cloud trends, but I think that one of the biggest trends that I have seen is that people want their clouds to do a lot more than they used to. When cloud started out, it was really just about virtualization. How quickly can I get some virtualized compute? And now it's about much, much more than that. So that's why that set of services is really important. And that's why things like bringing in GPU support as machine learning and AI take off, that's really important. Things like being able to upgrade so that you can take advantage of all of that innovation that's happening, it's really important. Operator-focused features like having longer maintenance periods and the ability to balance innovation and stability, really important. And when we look at our most recent release, which came out just a few weeks ago, it was called Rocky. It had improvements in a lot of those areas, and it had a lot of improvements, especially around managing bare metal clouds and physical servers. And this has been one of the most interesting things for me to see when I started a cloud company in 2005, and very early on in the shift. And at the time, what we all thought we were going to do was virtualize everything, abstract all of the hardware out of it, automate all of that, and then buy the cheapest possible servers and network gear that we could find, and the hardware was not going to matter anymore. And what we see happening now is hardware does matter again, and people want hardware, and they want bare metal, and they want FPGAs and ASICs and all of these different kinds of differentiated specialized hardware. But they want that speed and they want that agility that they got out of virtual servers and virtual hardware. And so when you look at some of the recent advances in OpenStack, you see the community responding to those needs and delivering on it. And I think that's really exciting. When you have bare metal clouds with physical servers that act pretty much like virtual servers, that's a very, very powerful kind of construct to have. And we mentioned Kubernetes already a few times today. I think containers are another component in the cloud world that are becoming really key for a lot of deployment scenarios. And so we continue to see a lot of integration happening on that front within the OpenStack services. So from an OpenStack perspective, kind of the core set of functionality and projects, we see a lot of growth, a lot of investment, and a lot of progress on the technology, and I think that's super exciting to see. But I said, I also wanted to talk a little bit about the trends and what we see at a bigger, kind of more strategic view. And that, to me, gets to differentiation. just tons and tons of differentiation. When you look at who is adopting these technologies, it's not just technology companies. It's retail, it's science, it's banking, it's a lot of traditional industries. And they bring with their use cases new requirements and different needs that we didn't necessarily think about 10 or 15 years ago, really, when we were just starting to create clouds and create this kind of a technology model. And like I said, I think the biggest theme I see is people want to do more with their clouds. They want to do more with OpenStack. They want AI. They want containers. They want serverless. They want all of these things, and they want to do it in more places. And to me, this is one of the things that I find most surprising, and is one of the ones that I probably would not have predicted as something that we would be working on within the cloud industry in kind of 2017 and 2018. But we want to take clouds, and we don't want to make massive at-scale clouds and centralized data centers as our only deployment. We want to take clouds and we want to put them out at the edge. We want to put them into our mobile networks. We want to put them into our retail stores. We want to put them in our coffee shops. And this is a big trend that's happening right now. And so that is driving interesting new use cases. So if you have one consolidated cloud in a data center, and you think about how you're going to manage the control plane, manage the uptime, manage the stability, there's definitely the work that you need to do to take that into account and deliver it. But that's pretty well, I would say, figured out now. And there are a lot of companies out there that have teams of 4 or 5 people who are running big OpenStack environments. But a company like AT&T has 100 cloud deployments and is going to thousands of them over the next few years. So how do you manage 100 or 1,000 or 2,000 clouds? And these are the kinds of things that we're working on now. So, do more with the clouds, do it in more places, and do it with different architectures, do it with a ton of different open source projects, and just continue to add more and more capabilities into these environments. So I think that kind of concept that we had 10 years ago, and that sometimes it's a myth that's still out there, cloud is consolidating, there's only going to be a handful of clouds, they're all going to be very similar. It's all going to be price-based. I think that that's totally false. And what we actually see is that cloud is diversifying because people want more and they need more from these technology stacks. So with that kind of world and with that kind of problem set, I think that it actually creates a ton of exciting opportunity for OpenStack and for our community. These higher level things that we're doing now, like serverless and containerization and machine learning, they're actually driving new and in some cases, more difficult requirements down to the infrastructure. And so that's kind of our specialty in the OpenStack world, is managing all of those bits of infrastructure, bringing them together and creating a sane way to work with them. And so when we think about this, we still think that the best way to go about this is definitely in the open and collaboratively. And I think that's one of the things that does set our community apart. But I think we're also seeing that open source on its own is not the only piece of the puzzle that you need. You definitely need the open source software, but there's so many options out there now. And it's exploding, the number of open source projects and the kinds of use cases that are coming down, that we actually need to think about doing more as a community to really solve these problems and deliver this kind of value. And so for us, we spent some time last year as a community doing some different strategic exercises with the board of directors, with the technical committee, with the user committee, traveling around and talking to different users. And what a lot of them said was that one of the biggest benefits that they saw from OpenStack was we had a community of people that really were willing to share their experiences, like Klaus and Patrice, who were willing to come together and talk about how they are integrating and operating and using all of these tools. And that was a huge benefit. So when we are looking at our community, we realize we're a community of people who build and operate open infrastructure, and we want to really think about how do we double down on that, and how do we deliver not just the open source software, but kind of overall bigger advantages. We talk a lot about users, and when we talk about users, I think sometimes we put up these kind of logo slides like this, right? And it's great, it's a lot of fantastic companies there, including City Network, for instance. But logos don't run clouds, people run clouds. And behind each of these logos, there are teams of people who are really operating these environments. And as you look at each of these individuals, they have tons of incredible experience to share. This is a team from Adobe, 4 people, and they run a production cloud for Adobe, high performance, 100,000 cores, critical to their Adobe Marketing Cloud product. This is Eli Young from Gap. He runs a couple of clouds within Gap to support their retail stores, including their point of sale systems. So very important job that he's got. And he's integrating OpenStack plus Cloud Foundry plus a bunch of other open source. This is Rodrigo from CERN at the Nuclear Research Agency. And CERN runs a massive OpenStack environment. I think it's over 400,000 cores now. They integrate with Ceph, they integrate with different open networking tools, they integrate with Kubernetes. They have 200 plus Kubernetes clusters that they run, and they also do hybrid cloud out to public clouds. On and on. You look at all of this and you realize, there's a ton of knowledge and experience. And so we want to come up with a strategy that lets us capture not just the software, but also the knowledge and the experience, and bring that out and share it more widely. So we've been working this year on some steps to try to deliver more value for everybody who's participating in the community. And part of that is what we call our 4 steps for integration. Because I believe that one of the toughest challenges that open source users face right now is actually an integration challenge. We talked earlier through a couple of the sessions about how if you want to move faster, you have to kind of break teams into autonomous teams, give them smaller deliverables, let them move at their own pace. That definitely lets you move faster. As someone back here said, it's the Linux philosophy. It's also the OpenStack philosophy. We're divided up into different teams. We release on a pretty rapid cycle. But as you expand that across not just 10 or 12 or 13 teams or a few dozen teams inside of OpenStack, but then you include all of the Kubernetes components and all of the open source storage components and all of the paths and all of the other things, you end up with an incredibly complex matrix of tools. And that can be very daunting and very intimidating as you start to try to wade into open source. But when you figure out what the right pieces are, like the LAMP stack that Johan talked about in the 2000s, you come up with extremely powerful capabilities. And so I think that we're at a phase where we need to think about integration, and we need to identify what those combinations are of different technology stacks, make sure they work together, and go deliver them. So we have 4 steps that we are working on right now to try to address some of these specific integration pieces. And the first step is really to scope what you're going to do, and that's you find the common use cases. So the LAMP stack was about a common use case of delivering a dynamic web application framework that could persist data. And so it put together an operating system, a web server, a database server, and a programming language with an interpreter. And as you look at OpenStack and you think about use cases, OpenStack's general purpose technology that gets used in a lot of different ways, but there are some common use cases. So things like containers are extremely commonly deployed within an OpenStack environment. Our most recent user survey, we ask a question about what technologies people run on top of their OpenStack clouds, and the people who answered that question, I think about 60% of them are running Kubernetes on top of their OpenStack environment now, which is pretty incredible. I think we're starting to see some patterns emerge here of the kinds of things that work well together. Kubernetes and OpenStack, that's an obvious one. And so containers overall, how do you integrate the networking, the security? How do you manage the deployment lifecycle within an OpenStack environment? That's a very clear use case that I think is a common one across the community. And we recently published it's kind of a white paper. It's kind of a high-level architecture document that talks about the integration points for OpenStack and containers. You can find that at openstack.org/containers. And the thing that's really cool about this is we go not just kind of at a theoretical level, but we get into details from specific users and their architectures and how they have approached this and how they are solving for running containers in their environments. So that's kind of the first step. We did the same thing for edge computing, and we put together a cloud white paper that talks about what do edge clouds look like, what are their attributes, what should they have in them, what kinds of technology components. And this has actually been a very popular piece of content that some people in the community put together. And it has delivered a starting point for a lot of people who are out there looking at kind of what do we do at the edge and what are the technologies that we need. So you define that use case, and that's the first step, and that gives you kind of a scope of what to work on. And then one of the things that I think is really important that we sometimes miss in the open source world is find points of collaboration across communities. Sometimes open source projects, they act a little bit like siloed teams within an organization, and they move at their own paces. They use different programming languages. They use different bug trackers, different communication systems, and for a user who's trying to put them together, that can create a lot of friction. We found, though, that there are some ways that we can collaborate through events like this. We actually have taken our OpenStack Summit and turned it into something that is much more focused on the open infrastructure community more broadly. So we have dozens of sessions on other open source projects. I think we had somewhere around 50 different open source projects that were represented at our most recent OpenStack Summit in Vancouver. It's going to be the same thing in Berlin at our next OpenStack Summit. And when you bring those communities together, then you start to realize where you might be causing each other trouble. and sometimes it's just a matter of taking a minute and realizing, okay, you know what, we haven't updated this component and we didn't realize you were depending on it, and you get a couple of developers to have a very brief conversation, and it solves some issues. We've been doing a lot of this kind of collaboration with some of the key open source integration technologies for OpenStack, like Ceph and Kubernetes and others, and we've seen some great progress. In the Kubernetes world, for instance, Kubernetes has a concept of a provider, which is basically like the driver for the environment that Kubernetes runs on. Those used to all be managed separately within Kubernetes. We started talking with some other developers in the Kubernetes community, people who were users across these different drivers, and realized that there was an opportunity to standardize how that layer of Kubernetes worked. It's really the integration layer for Kubernetes with everything else. And the Kubernetes community created a cloud provider SIG that is now standardizing how all of their cloud providers work. That includes OpenStack, AWS, Azure, Google, and one of the OpenStack Foundation employees is actually the chair of that SIG. And so, a little bit of collaboration like that can end up going a long way when you have projects that need to work together. Sometimes, though, what you realize is that the collaboration reveals that there are technology gaps. And sometimes, it's not just a matter of working together and fixing a couple of integration points, but there are actually entire spaces that need to be filled in. And so one of the things that we started doing this year at the OpenStack Foundation was hosting additional projects that are targeted at filling gaps within infrastructure. Kata containers was the first one we did. Zool is one that came out of the OpenStack community. And we have a couple of new ones that we're going to be kind of launching around our Berlin Summit in about a month, Airship and Starling X. just to touch on each of the new ones real quick so you get an idea of what they are. Kata containers is a very specific type of container runtime that uses lightweight virtualization technology to provide isolation around a container. And so if you are in a regulated environment, if you are in a very large multi-tenant environment, you may not feel comfortable relying on just the isolation that run C and C groups and the kind of Linux container pieces get you. You might want something extra in there. And this is how the large public clouds run their container products and their container solutions. And so this is a community project that started up earlier this year, and it was created by Intel and a startup called Hyper.sh. They basically had both developed similar technology. They agreed to combine it, open source it, and work together and collaborate on this. And since they launched it, there have been a lot of other companies that have gotten involved. The technical leadership is made up of an architecture committee that has representatives from Google Cloud, from Intel, from Huawei, from Hyper. So it's had a lot of involvement. Microsoft as well was on the architecture committee. So it's a really interesting piece of technology that was kind of missing, and it's something that the hyperscale public cloud providers have been building on their own, but not collaborating openly. And so we at the foundation said, here's a way that we can bring people together so that everyone has access to this type of technology, not just kind of the giant technology behemoths. You can find out more about that at katacontainers.io. The second one I mentioned was Zuul, and Monty, I think, is here somewhere and did a session yesterday, and I would love to talk about Zuul more today, I'm sure. But Zuul is a CI system that actually came out of the OpenStack community. The OpenStack development team is massive. The velocity of change that happens is very, very high. And we actually couldn't support that with just Jenkins and some of the standard CI systems that were out there. So over the first few years of OpenStack, the community built a CI system, which is called Zuul. And Zuul is really a gating tool, which is where the Zuul name comes from. But it allows you to test very complicated dependency sets across distributed systems and not allow the code to merge until all of those tests are passing. So it's one of the things that has allowed OpenStack to continue to move very rapidly while having thousands of developers that are spread out all over the world working on a very large and interdependent code base. And this is now a project that we have kind of opened up and split out on its own. It works very closely with Ansible, so if you're using Ansible, lots of great integration there. It also works with not just kind of the OpenStack software development workflow, but GitHub, and it's a very powerful system that companies like Wikipedia and BMW and GoDaddy and others have started using within their software development processes. The other two, I said they're just getting started, and the first one is an edge-focused cloud distribution. It's called Starling X, and Starling X delivers the kind of basic standard cloud functionality that you expect: automation, virtualization, APIs, but it does it in a smaller footprint, and it has some additional services to manage HA for the workloads that are running in that cloud. This is a project that opened up from Wind River and Intel and came out of some of the commercial technology that Wind River has developed and deployed inside of industrial IoT deployments and different kinds of very high performance and latency sensitive kinds of environments. And the final one is called Airship. I mentioned earlier that AT&T is deploying hundreds of clouds and eventually thousands of them. And Airship is the technology component that they have built to manage that. As you think about how you're going to go from kind of one or two clouds to dozens or hundreds, the number one thing that they have as their goal is zero-touch operations. It can't require a human to go physically interact with the environment on a regular basis. Otherwise, it's going to be completely impossible for them to do that. So Airship combines a number of open source technologies into this kind of integrated stack that includes OpenStack, Kubernetes, Ceph, Tungsten Fabric, and a couple of others. But it delivers this all in a way that's fully automated and can be pushed out to a lot of locations. SK Telecom is also involved in this, as well as some other companies. So this is a new one too that's just getting off the ground, and you can find out more about it at airshipit.org. But as you look at all of these, the goal that we have is to bring in different technology approaches to kind of combine them all together and fill in these gaps that exist on the technology side. And then once you do that, you have to test it all and repeatedly test it all. And we have some testing initiatives too that are underway. Open Lab is actually probably a really good one to pay attention to that takes these different stacks of open source technologies and just does repeated testing on combined integrated deployments of them. So as different versions of these software components move along over time, they continue to be tested so we can find out as soon as there are gaps. One example of that is getting OpenStack into the CNCF testing dashboard so that you can see how it works with all of the CNCF components. We think those 4 steps, that's not going to solve everything, but it's a start to getting people to think about integration, to getting people to think about open source components as kind of parts of the entire solution that companies want to build to go out and do what the bank that we just heard from is doing. What they are trying to do is deliver features to their customers faster and faster. They're not trying to find open source just to find open source. And so we have to think about it from what problem are we all trying to solve together. And these 4 steps are a start. And so I think that our kind of mantra this year for the community overall has been we want to take open source, we want to make it open infrastructure, meaning we want to take those open source components, we want to integrate them together, we want to make it so that people can run them reliably, at scale, in production, so that their businesses depend on it. And I think that's an awesome mission for us to kind of carry on from where we started with just trying to open up cloud and really, something to build on and go after these huge opportunities that we see out there with all of these use cases. So a couple of final points. I mentioned that our next summit is going to be in Berlin, and this is in just about a month, November 13th to 15th. It's the closest that the summit will be to Sweden for a couple of years. So if you're interested in meeting more users and developers, I encourage you to attend and try to make time to get to that. After that, we'll be in Denver next spring in April. And that's it. So thank you all. I think I'm at my time, so I will hand it back to Oscar.
Thank you so much. Any questions for Jonathan? We have time for a quick question, I think.
Okay.
Over there.
Then Paul. Okay, so it's on. Yeah, thanks. Okay. Thanks. Damn it! It's blank. It's gone. It's gone. I'm sorry.
Okay. Well, I'll be around if you think of it. Feel free to.
I'll catch you later.
Okay.
Any other questions for Jonathan? All right. Thank you so much, Jonathan.
Thank you.